So an integral is basically just the area, right? Yeah, so you just do it by drawing a picture and doing it.
Wow, yeah. It's so good.
Do it. No, you just draw a picture. The first one is...
I don't know what you're talking about.
Yeah, it's just a triangle.
5 times 49.
Oh.
Well, you
Oh no!
camera's good?
What am I saying?
DJ, duck your head. More. There you go, hold it.
Forever?
Yeah.
Yeah, so what's this? Exactly. That's like literally what an integral is. If you want to be a little bit more, if you want to go into a little bit more detail about it, then what you would really do, technically, is you'd go from 0 to 5, and you'd split this up into a bunch of subintervals. You'd use whatever process you want, say RM, and you would do this, and things would happen, and you'd get these things, and then you'd add up all those guys, and then you take the limit as n goes to infinity. But that just is the area, right? So if the area is just yields like a shape that you know how to find the area of, then this is called like doing integration by picture, / geometry. Okay, good, keep going. What's this one? Yeah, exactly. 1, 2, 3, 4, 5. There's 2, there's 5. 7 is way up here. So this is just the constant function 7 from 2 to 5. So it's just a rectangle. Okay, go. Do the rest.
You need to like rotate the camera.
No, just keep going. There we go.
I went across.
Oh,
No. Why do you it's a 2 here, right? Or is it like
I got that 4 times.
The top one, that's like one to 4.
But it just like
Average up the bases. You guys getting these all right? I think I did that right.
I don't need you guys rolling me getting held back by the mic bowl.
Oh, it's 3 by 3, yeah.
Oh, yeah.
It's just like
Skip it. What's happening?
Okay, I'm sorry. Still wait.
It's 2/3 if it's a square, so that's why it's doesn't that work this way? No, it's not over 2. Big triangle and not a big
Yeah. This one we just kind of like learned already is 1/3, right? But if we had a little bit, if we had a little bit more time, what could we do right now? Like actually do it. Yeah, so like you do things and you get things, and right? That would be like I over n, and you plug it in. So actually, it's not even that hard, right? Because this is the limit as n goes to infinity of the sum from I equals 1 to n of, bless you, the square of I over n times the width of each subinterval, which is 1 over n. And if you did that out, I promise you, you would get what, actually I could probably do this in like 5 seconds, right? Because this is 1 over n cubed times I squared is n plus 1, 2n plus 1 over 6. Is that 1/3 as n goes to infinity?
Yeah.
It just like is, yeah. So it's actually not even that hard. All right, what's this one?
It's 49 cubed.
Yeah, this is a half circle. Actually, it's a quarter circle. So this is 49. Alright, how are we doing? Good, last one. Most important one of all.
There was another one?
Yeah, there's one more.
Film. Ian, smile. No, it's fine. You're not in the way. There. No, neither of you are in the way.
This doesn't go through
Oh, -4 to 2.
Alright, so this is the most crucial thing of all, and here we start to understand whether you really understand what an integral is. Because after all, what is the integral from, what makes this from kind of like a little difference?
Negative.
Yeah, there's like sometimes negative, right? So suddenly we realize, aha, it's kind of correct to say that the integral is the area under a curve. That's what you would say to like your parents if they asked you. Don't tell anyone who's younger than you anything about calculus because that would be unethical. But parents, you can give up on that. It's too late for them. So if they say, yo, what's an integral? You'd be like, well, it's basically the area under a curve, but I won't go into details because you wouldn't understand. But really, it's not quite the area under a curve anymore because like, actually, what is this? It's like the limit as n goes to infinity of the sum from I equals 1 to n of f of x of I star delta x. In other words, what you're really supposed to do if you want to figure out this integral is go through the interval from -4 to 2 and split it up into subintervals, right? And then what do you do on each subinterval? Pick an arbitrary sample point. I will choose the midpoint, and then you do things. Now I'm drawing, but of course this picture that I'm drawing, though beautiful, is not really the math, right? The math is here in the definition. And so, but this picture kind of helps me think about what's going on a little bit. Let me just finish drawing it. Okay, so wait, final things, the bell's gonna ring in a minute. What happens when I plug one of these numbers into the function on the interval from -4 to 0? I get something negative, right? So the integral, or the Riemann sum rather, is going to be, this part of it is going to be negative, times the width, which is positive. Therefore, how is each one of these rectangles going to contribute to the overall Riemann sum? It's going to contribute negatively to the Riemann sum, right? This Riemann sum really is, though area inspired us, it's not quite area. It's just products of values of function and widths of intervals. So each one of these upside down rectangles, not a technical term, is going to contribute negatively towards the Riemann sum. Therefore, what is the actual answer to this integral? -6. Yeah. Because there is like area 8 underneath and area 2 above, and negative rectangles counts negatively. By the way, hold on before you pack up. This actually makes total sense, because if this is a velocity versus time curve, then talk to me about what is the significance of this? Everybody want to do this as well? Yes, exactly. If this is a velocity versus time curve and my velocity is negative here, what does that mean? That means you're going backwards. So the interpretation of this graph is that the area underneath is how much distance I move backwards, right? And then this is how much distance I move forward. So what's the meaning of the -6?
That means you move to the left.
It's the like overall change. It's like the displacement. All right, good. How we feeling? Good. I'm turning off this camera. Bye, internet. There's a packet called